Hello, my name is Jake Monroe. Today I will be sharing my project, Apical. Spokane, Washington has always had a strange relationship with its resources. It boasts having so much when in reality it has always been a distribution hub, not really producing anything. All of the resources it claims as its own come from hundreds of miles away. This decentralized distribution system is causing more and more problems in Spokane, as well as the rest of the world, as urban centers, which often adopt a similar distribution system, are growing faster than ever before. In particular, food will be an issue as people move away from where it's grown. This map shows the allocation of farming types on a 25-hectare grid. A filled spot means there is 1 acre of farming allocated in that area. We begin to see the area around the city of Spokane is not farming at all. The square above is the land that would be needed for farming to sustainably support the 2040 Spokane population. This is even more worrying when we take away all farming not for human consumption. Spokane's food issues are apparent within the city as well. The site is located within a food desert, meaning there is no supermarket within a reasonable travel amount. The site is also located in one of the most cost-burdened regions in the city. When we look at who's living in the area, it is primarily college students there for the universities to the north. Studies find that college students' eating habits have been in decline in recent years, citing that cost is the biggest factor in making poor eating choices. This trend is found in other low-income populations as well. This is because of the food distribution issues that cities face. 30% of fresh foods are spoiling during the distribution process, making specifically fresh foods significantly more expensive. We can also not afford to waste this much food. It is predicted that in the next 30 years, we will need to grow as much food as the rest of human history combined to keep up with our growing populations. These issues are not only found in Spokane, but around the world. This map shows counties in the US with a 20% poverty rate, as well as 50% of people living in a food desert. The right to healthy food should not be reserved only for the wealthy. These two issues go hand in hand. So we begin to ask, can an urban farming infrastructure typology be used to create resources for new housing developments? Phase 1 of Apical then begins. Phase 1 recognizes the state of flux the site sits within. This current industrial zone is changing to primarily residential and office over the next decade. The first floor puts into place 7 farming towers and a supermarket, laying the food infrastructure in place to support the future residential demand. This fits in with the current industrial neighborhood rather than gentrifying the area with all the housing projected to be needed in a decade. Vertical hydroponic farming creates more possibilities for farming to be done within the city because of its extreme efficiency. The area needed to feed Spokane's 2040 population dramatically decreases. Stacking this land vertically in towers again divides the land needed for feeding the city. These towers act self-sufficiently, housing all necessary pieces for food production. Each farm can produce 18,000 pounds of food per year. Fish are farmed and the nitrates from their waste are stored in the water. This water is then used as both irrigation and a natural fertilizer. However, 40% of the organic matter the farms grow cannot be eaten. This waste matter is dried and ground into a fine powder and mixed with sawdust and the same bacteria that turns sand into coral. This mixture is packed tightly into a form and sits for 3 weeks at room temperature. From this otherwise waste material, each farm will be producing 20,000 bricks per year nearly passively. These bricks begin to take a farm-to-table concept of distribution and put it vertically on the site. The towers use radial carousels for energy efficiency, maximizing the footprint of each farm. The fish farming is put on display both in the public spaces, becoming a public aquarium, and the interiors of the farm as well. Once bricks are being produced, phase 2 can then begin. As bricks are produced, housing can slowly be built from them over a 15-year period. This starts to create a new entirely on-site life cycle for a large portion of materials used in construction. By farming and producing these bricks from the waste from the farm, the residential units combined with the farming towers have a fraction of the carbon footprint as only the residential units would have if built with typical construction methods. Phase 3 starts at year 10. We begin to see the residential come together. The units and plan are designed as a set of details and relationships rather than a fixed floor plan. This way, the form and program can adjust as the needs of the community will inevitably change over the 15 years of construction. The units in this way act more as a suspended neighborhood rather than an apartment block. When construction is finished, building enters phase 4. Here we see the total of the building's production. The bricks produced after on-site housing is complete can be used for more housing projects in the area as a cheaper, carbon-positive local alternative. In section, we can see how the farms act in structure as a platform for neighborhood growth as well as a means for their material production and the direct connection the residents now have with the farming infrastructure. This building typology is not bound by this particular site because each farm tower can act independently. This methodology can be scaled up and down to address the housing and food inequalities that plague so many people. If an open lot has room for one tower, it can quickly, effectively, and sustainably begin to produce the food and materials that bring the right of healthy eating and living to everybody. Thank you.